Okay, so this is a chapter 3 assignment. Okay, so first one, you walk in a straight line for 95 meter at an angle 162 above the positive x-axis. What are the x and y component of your displacement? Okay, so the vector here is, you see, 120, 162. So this is x-axis. So this guy is 162 degree. So this is vector 95 meters. So from here to there, this is 95 meters. All right. Ask you x and y displacement. So we know, so we call this vector A. So AX equal to A cosine 162, right? So A will be 95 cosine 162. Okay, so this will be negative 90.3. So this is your x component. AY equal to A sine 162. Okay, so this is 95 sine 162. This equal to 29.3 meter. Okay, so that's your x component and y component. So very simple. Give you a vector, whatever vector, we call this vector b, right? So look at angle, okay? And bx equal to b cosine theta, by equal to b sine theta. Okay, so that's the equation. All right, number 2. A vector has a component ax is 22 meter, ay equals 13. Okay, so this is a vector ax 22 meter. So this is ax, ay 13. So this will be ay. All right. So we know the components of vector, and then you can combine them together. This is your vector, right? What is the magnitude of the vector? So a equal to square root of ax squared plus ay squared equal to 22 squared plus 13 squared. Okay, so just make the calculation. What angle does this vector make with the positive x-axis? So angle equal to inverse tangent of ay over ax equal to inverse tangent of ay will be 13 over 22. Okay, so you do inverse tangent and you get an angle. So inverse tangent, you get an angle 30.5 degree. All right. Now you have to check if this is the right angle. Well, for the first quadrant angle, a y component is positive, x component is positive. And also third, if you get this angle, but it's in the third quadrant, both of them will be negative. Okay, so now you check. Ay is positive, yeah. Ax is positive, so first quadrant, then this angle is right. If both of them negative, then whatever angle you get here, you have to add 180. Okay, so that's it. This is the first quadrant angle. That's enough. That's good enough. So this will be 30.5 degree. Number 3, a vector has the components ax 30, negative 36, ay 43. What is the magnitude of this vector? So this is very simple. A magnitude equal to ax squared plus ay squared equal to ax negative 36 squared plus 43 squared. Okay, so you make the calculation. What angle does this vector make? Okay, so angle equal to inverse tangent of ay over ax, right? Inverse tangent of 43 plus divided by negative 36. Okay, so let's see what we get. If you got this one, okay, so let me get my calculator. Inverse tangent, right? So this one, inverse tangent, 43, 36. Okay, so whatever we get here is negative 50.1 degree. Okay, 50.1 degree. Okay, all right, so that's what we get. Now let's check the angle, you see. So this AX is negative, right? So negative AX, negative. AY is positive. Okay, so positive over negative, right? You get a negative angle. Negative angle somewhere here. So negative 50.1 degree, right? But this actually is a third quadrant. For this fourth quadrant will be AY is negative, AX is positive. But this one is positive negative, right? Which means this angle is not right angle because this is a fourth quadrant angle. So you have to, whatever this one, plus 180. Okay. So what you got here is 130. It's about 130. Okay, so you have to add 180 to push this angle into second quadrant. Okay, so whatever angle here, add 180. Okay, so basically this is the angle you get 130 from x-axis, right? So go all the way there. So that's the angle you should have. Okay, this is second quadrant angle. Second quadrant vector. So the vector here is this. This is vector, second quadrant. All right, number 4. Vector A has a magnitude 50 units and point in the positive x direction. Okay, so positive x direction, right? So this is x and y. So this is A, 50 units. Second vector B has a magnitude of 120 units and point at an angle 70 below the x. Okay, so 70, this is a B. 70 below 70. So basically it's a negative 70 degree. All right. Which vector has the greater component x components? Okay, so AX is A. You see angle here is 0, right? So cosine is 0. A is 50. Cosine 0 is 50. AY equal to A sine 0 equal to 0. Let's see, 1 minus 50 sine 0 equal to 0. Okay, so this is components. AX, AY, BX. B cosine, and this is negative 70, right? So equal to 120 cosine negative 70, okay? BY equal to B sine negative 70, right? So equal to 120 sine negative 70, okay? Negative 70 is a negative value, so this is BY, right? BY is a negative something, all right? So so compare which one got a bigger x component. You have to compare this one and this one. Which one is bigger? And greater in y components. Well, so AY is 0, AX, BY is negative. So this is bigger. This is greater. Okay, so just make it direct comparison. All right, so that is number 4. Number 5. The vector A has magnitude of 40 meter and point in the direction 20 degree below the positive x-axis. Okay, 20 degree below. Okay, this is A vector, so A vector, 40 meter, so 20 below x. Remember to put a negative 20. This is a negative 20. So because you come from x-axis, rotate clockwise to this vector will be negative 20 degree. Second vector, B has a magnitude of 75, so A is 40 meter, 75, and point in the direction 50 degree above. Okay, so B bigger, B 75 meter, and this is 50 degree. All right. Using components method of vector addition, find the components and direction of the C. C equal to A plus B. Let me see what's the C. Oh, C equal to A plus B, right? Okay. Components method, because C equal to A plus B. Okay, C equal to A plus B. Components method says that Cx equal to Ax plus Bx, Cy equal to Ay plus By. All right. So what is Ax? Ax is, you see, 40 cosine negative 20. Okay, so this is Ax. What's Bx? Bx equal to, B is 75, right? 75 meter. 75.0 cosine 50. Okay, so this is Cx. You see, you just find the components, put them together. Cy equal to Ay. Ay is 40 sine negative 20, right? And the By is 75 sine 50. Okay, well, this is a Cy, right? This is Cx, Cy, Cx, Cy. And you just make the calculation. Then what is the magnitude? Magnitude, right? So magnitude, C equal to Cx squared plus Cy squared. So whatever you calculate here, plus whatever you calculate here. And you just do the square and square root. Angle, same thing. So theta equal to inverse tangent of Cy over Cx. You see, you have Cy, you have Cx, and you do tangent. And make sure you have a right triangle, or right angle, right? So it looks like this is B, right? So A and B add together. So you can tell if you add them together, this will be so it will be a first quadrant angle. Okay, so C, X, Y both positive. Okay, so whatever angle you do from this unit tangent function will be the angle, this right angle. All right, so that's number 5. Number 6. Initial velocity VI is 45 km per hour in the positive x direction. Okay, so this is VI. (45 kilometer per hour). The final velocity VF is 66 km per hour in a direction that 75 degree above the positive x-axis. Okay, so 66, right? So here, this one, VF. Okay, this angle is 75 degree. And look, changing velocity, VF minus VI, find the magnitude and the direction of the changing velocity. Okay, so changing velocity equal to VF minus VI. All right, so this is the equation you use. Components method, right? Changing velocity of the x component equal to VFX minus VIX. Okay, so VF, this is VF, right? 66 cosine 75 minus this guy's x component, right? So this guy actually angle is 0, so this guy is on x-axis, right? So x component will be 45. Actually 45 cosine 0. Cosine 0 is 1, so it's 45. So that is Vx, changing velocity x direction. Vy equal to Vfy minus Viy. VFY is 66 sine 75. And initial velocity, there's no y component, right? Minus 0. Or you can see it's a 45 sine 0. Sine 0 is 0, so this is 0. So this guy's gone. And this is your y components. Okay, and then find magnitude direction. You see, magnitude delta v equal to square root of delta vx square plus delta vy square. You see, delta vx, delta vy. And angle equal to inverse tangent delta vy, delta vx, right? You look at difference. Okay, difference, delta vy is basically is positive, right? Delta vx will be, let me see, this one, 45, 66. Well, actually, this will be negative. This will be, let me calculate. So this is a 66 cosine 75 minus 45. Ooh, negative, right? So this is a negative. So this guy is vx negative, vy is positive. Okay. Then you do the inverse tangent function. So vx, vy is positive, vx negative, right? So this guy will be the second quadrant angle. Okay, so when you do the inverse tangent, top is positive, bottom is negative, right? So you have, when you do the inverse tangent, you get a equal to something negative angle. Okay, and then you look at this diagram, you can tell this guy is in the second quadrant. All right, so you have angle will be whatever you get here plus 180. Whatever you get from this calculation, use a calculator, plus 180. To push angle into, so this is a negative angle, the push angle into the second quadrant, you have to add 180, okay, because this is the second quadrant angle. All right, this is number 6. Number 7. All right, a basketball player runs down the court following the path indicated by the vector A, B, C. You see, A, B, C. In the figure, the magnitude of the vectors 10, A 10, B 20, C is 7. Find the magnitude and the direction of the net displacement of the player using the components method, right? Net displacement, you start from here to the end, so this will be the net displacement. Okay, so displacement, we call the resultant displacement equal to A plus B plus C. All right, so we use components method. Rx equal to Ax plus Bx plus Cx. Ry equal to Ay plus By plus Cy. All right, so what is Ax? You see, this is A, right? So we write out this way. So this is X, this is Y. A, right? A is 10 meter, and this is direction down, right? So what's the angle? So angle here is 270. You see that? 270. And also you can tell from this diagram, you can tell AX is 0, right? So equal to 10 cosine 270, right? This is 270. AY equal to, you see, negative 10, right? This, just by looking at this, you know, y component is negative, right? And also you can, if you stick to the angle, right, 0.2 sine 270. Sine 270 equal to negative 1. Okay, cosine 270 is 0. Okay, so this is AX, AY. Same thing here, you can break down bx, by. So b here is 20. Okay, so you see 45 degree. So bx equal to 20 cosine 45, by equal to 20 sine 45. Okay, then you look at the c equal to 7, right? 7 meter. And angle here, you see 30 below, right? So this is a negative 30. So cx, cx equal to 7 cosine negative 30. cy equal to 7 sine negative 30. All right. So just plug, you see, ax, bx, cx into this equation, find rx. Same thing, you find ay, by, cy, plug here, find the ry. Okay, resultant components of the vector, right? Then ask you about the magnitude and the direction of the net displacement. This guy, right? Magnitude, you see, very simple. R equal to square root of rx squared plus ry squared, right? And theta equal to inverse tangent of ry over rx. Okay, so figure out rx, ry. Use those two equations to figure this out. Make sure you push this in the right quadrant. Compare, find what is the sign of rx, ry. Okay, and it turns out both the sign will be positive, right? Both of them positive, so you will end at the first quadrant. Okay, so whatever angle you get here is a right angle. Okay, so this is number 7. Number 8. A vector A has a length 6.1 meter and a point in the negative x-axis. Okay, so A. So this is A. 6.1 meter. Find the x component and the magnitude of the vector negative 3.7a. Okay, so this is a vector, right? So what's this vector? This is a vector, right? So a, and then the magnitude of a equal to, you see, this is 6.1 meter, right? Direction, this is direction. It's basically it's 180, right? Okay, this is 180. Find the x component. Okay, of this guy. Okay, so what is this guy? Negative 3.a, right? X component, right? So this guy is, you see, is, okay, so so you times 3.7 and negative that, right? So whatever this guy's magnitude, okay, so negative give you the direction, whatever this guy's magnitude times 3.7. Okay, so 3.7. Okay, so this is that vector's, this vector's magnitude, x, let me see, magnitude x component, right? So basically you times negative 3.7. This is a. So this is a, right? And 3.7, so we make a 3.7 times longer, and then negative, you flip the direction. Okay, so this is negative 3.7a. Okay, so this vector. What is this guy's magnitude? What's this guy's x component? X component, you can tell this guy is in the positive direction, right? So x component will be 3.7, 6.1. You see this guy's x component, the direction will be 0, right? So this is x and y, all right? B, the magnitude of this vector. Well, the magnitude of this vector is the same as your x component because this guy is on the x-axis. Okay, same thing, 6.1, 3.7. All right, so that's this problem. You see, this is the original vector, and then negative 3.7, this vector. Remember to turn the direction. Okay, next one. Find the magnitude and the direction of the following vector. Okay, so A, you see, this is vector components, right? So basically this AX, this AY, this AY. So A equal to 22 square plus negative 14 square, right? Theta direction equal to inverse tangent of AY over AX, negative 14 over 22. Okay, so when you do this one, they give you a negative angle. Okay, whatever negative, right? And negative, and then you have to check the quadrant. Okay, so AY is negative, AX is positive, right? Negative and positive is in the fourth quadrant, and so whatever angle you get here is a right angle. Okay, you will do the same thing for B. Now A plus B. So first, what is A plus B? A plus B equal to, just add A together. You see A, right? So this is 22 plus 22.5, 24.5 x, and then you add y together, right? So plus, you see, negative 14. So this is positive 13, right? So add them together is negative 1y. Okay, so 24.5, and this is negative 14. Let me see. Yeah, negative 14 plus positive 13, right? So you can end up with, okay, negative 1. All right, so what is the magnitude and direction of this vector? Well, magnitude of direction is, so magnitude 24 plus 0.5 square plus negative 1 square, okay? So this is magnitude. Direction, inverse tangent of negative 1 over 24.5. And you can tell this is also, you see, negative negative y components, positive x components is still in the fourth quadrant. Okay, so whatever inverse tangent, you get right angle. Let's see one more. What is B? A minus B. What's A minus B? A minus B. You see A minus B. So basically A minus B equal to, you see, 22 minus 2.5 x plus negative 14 minus 13 y. Okay, so this is 19.5 x minus 27 y. Okay, magnitude. Okay, so this is magnitude. Direction, inverse tangent, negative 27, 19.5. And so the angle here is negative, and then you can check if this is a y is negative, x is positive. Yeah? So it is fourth quadrant vector. All right, let's see what is B minus A. B minus A equal to, you see, B 2.5 minus 22x plus 13 minus negative 14y. All right, so equal to negative 19.5x plus 27y. Magnitude, same thing, right? Square root 19, negative 19.5. Remember, square plus 27 square, right? So this is magnitude. Direction, inverse tangent of 27 over negative 19.5. Okay, so this is, you get here is a negative angle. Okay, and then you have to check the quadrant, right? So y is positive, x is negative. You see, you have to, whatever you get here, plus 180, you push to the second quadrant. Inverse tangent function give you either first quadrant or fourth quadrant. you have to add 180 to push to the right quadrant. Okay, so that is this question. All right, number 10. You drive a car 1,500 feet to the east. Okay, 1,500. This is east. And then 2,500 to the north. Okay, so, okay. If the trip took 3.0 minutes, what was the magnitude and direction of your average velocity, right? And here is a feet per minute, right? So total is 3 minutes. All right. Well, average velocity equal to displacement over time, right? Displacement. This is your displacement, right? You see, average velocity, displacement, and also direction, right? Displacement. You see, this is a C vector, right? So A, B, you see, C equal to A plus B. Okay. So Cx equal to Ax plus Bx. We know Ax is 1,500, so whole thing is on x-axis, right? Bx is 0, B will be in the vertical direction, right? So 1,500. Cy equal to Ay plus By. You know, Ay is 0, right? So By, so B will be 2,500. Okay. And then what is the magnitude C? So C magnitude 1,500 square plus 2,500 square. Okay, so this is magnitude, right? That is displacement magnitude. All right. So whatever this displacement average velocity, right, equal to C over time. Okay. So the magnitude is C magnitude, right? So average velocity magnitude equal to C magnitude divided by time. Okay, so equal to this value divided by 3 minutes. Okay, whatever it is. Direction, you see, so this is displacement direction, right? And you know, this displacement direction will be your average velocity direction. Okay, because average velocity equal to displacement divided by a scalar time interval. Okay, so this guy will have same direction of this one because this is divided by divided by a scalar. Okay, just like this. You see A and 1/3 of A, right? Those two vectors will be from the same direction, but the magnitude will be different, right? So you figure out the magnitude of your average velocity direction, this angle. Okay, so you see theta equal to, you see this angle, right? So this is a right triangle, tangent theta. So theta equal to inverse tangent of this is 25 divided by 1/1500. Okay, so this is the first quadrant angle. So this angle will be the velocity direction. Okay. All right. Number 11. A police car travel at 3.0 meter per second due east. Okay, so this is a police car, 30.0 meter per second due east, while in pursuit of a vehicle that is travel at 33.5 due east. Okay, so this is the police of car VP. Okay, so this is chasing, right? 33.5 meter per second due east. All right, so this is the car. What is the velocity of the vehicle relative to the police car? Okay, so basically what you're looking for is the car relative to police. All right. So this equal to v car to the ground. Okay. So this velocity actually relative to ground. This is police officer car also relative to ground, right? So plus v ground p, right? So we make the closed loop. You see, car relative to police equal to car relative to ground, ground relative to police, right? All right, so what is this is one dimensional. So what is the CG, right? CG equal to 3. Okay, so this is car to the ground, right? So this is car to the ground. And then ground to the police, right? Ground to the police. So this is police to ground, ground to police, just like opposite that, right? Opposite that means minus 38.0. Okay, so your speed, okay, so your speed is, so this one is negative 4.5 meter per second. So what is the velocity of the vehicle relative to the police? You see, to the police, in police officer's eye, right? You actually go this direction because this is negative. Okay, so that is relative velocity. What is the velocity of the police car relative to the vehicle? You see, VPC, right? Police car relative to the car. Police officer to relative car, right? So VP ground plus V ground car, right? This guy is 38, right? 0.0. This is the C ground and the ground C. Ground to the car. You see, this is negative. So in this vehicle's point of view, police officer car go this way with 4.5 meter per second. In police officer's point of view, this car actually go this way, 4.5 meter per second. Okay, so this is relative velocity. Okay, all right, last one, 12. A passenger walks from one side of a ferry to the other as it approaches a dock. If the passenger's velocity is 1.5 meter per second due north relative to the ferry. Okay, so this is the passenger ferry, okay, equal to 1.5 meter per second due north, right? And 4.50 meter per second at an angle 30 west of north. Okay, so this is north, right? 30 degree west of north. Okay, so this is V relative to the this relative to water. Okay, so passenger to the water. Okay, so this is 4.50 meter per second. What are the magnitude and direction of the ferry's velocity? Okay, so looking for ferry's velocity relative to the water. Okay, all right, that's it. So this equal to V ferry to passenger plus V passenger to the water. You see, make a closed loop, right? So ferry to passenger, passenger to water equal to ferry to the water. Okay, so you see, what is this? This actually, you see, passenger to the ferry, right? So ferry to the passenger will be opposite. Okay, so this is 1.5 meter per second, right? Person to the ferry is due north, then ferry to the person due south, right? And then second vector here, passenger to the water, right? So you add the second vector, Okay, so this is the second vector. Okay, so what do we do here is you can use the components method, right? So v ferry to the water x equal to v x plus v p w x, right? You see ferry to the passenger. So this is the ferry to the passenger, right? X is 0. What is this guy's x? So passenger to the water, right? Passenger to the water. So this vector, what is x? So you break down this vector into x and y, right? X here, this is a 30, right? If this is 30, then the angle here is 120, remember. This is a real angle you're looking for. So this will be 4.50 cosine 120. Okay, so this is this guy's x component. VFWY equal to VFPY plus VPWY, right? So what is FPY? So this is FP, right? So this is all in the y-axis, so it's negative 1.50 plus 4.50 sine 120. Okay, so you get the resultant vectors x component and y component, right? So ask you about the magnitude, right? So magnitude v ferry to the water equal to, you see, vf water x squared plus vf water y squared. This will be the magnitude. Direction, okay, vf wy vf wx. So 4.5, you can tell this will be positive, right? This will be negative. Okay, so positive, negative. Okay, so you have whatever we get here is negative angle. Okay, then you look at the quadrant. You see positive y, negative x is in the second quadrant. So whatever angle here got here, you have to add 180 to push to the second quadrant. Okay, let's see. You see, if you use the graphic method, this is your FP, right? And then you add this guy, right? And the resultant vectors are from the tail and at the tip, right? So this is the resultant vector. You add them together. Okay, and find this guy's magnitude and direction. Okay, so that's the relative velocity. All right. Okay, so that's all for this chapter.